sequential sampling plan. That means here we are going to take sample one after other until we can make a decision regarding whether to accept a lot, reject a lot, or continue with the process of taking samples. Okay. In sequential sampling, a sequence of samples are taken from the lot and allow the number of samples to be determined entirely by the results of the sampling process. So in the previous cases, in the sampling plan itself, sampling plan means that includes the sample size, and we are going to pick that much of samples from the lot. But in case of sequential sampling, the number of samples is not decided. Okay, we don't know. So how many samples we are going to take. So that will be decided by the process itself, depending on how many defectives we are going to get. So in sequential sampling, a sequence of samples are taken from the lot and allow the number of samples to be determined entirely by the results of the sampling process. In practice, sequential sampling can theoretically continue indefinitely until the lot is inspected 100%. Okay, in worst case, but we don't allow it to go to that extent. But in worst case, we may end up with evaluating entire lot. Okay, but we have a different approach in order to avoid inspection of all the units in a lot. But sequential sampling plans are usually truncated. That means so they are ended at that point. Sequential sampling plans are usually truncated after the number inspected is equal to 3 times the number that would have been inspected using a corresponding single sampling plan. Suppose for the same lot, if we adopt single sampling plan, so what will be the sample size? Okay, based on that we will decide when to stop the sequential sampling process. Okay, suppose for example in single sampling, suppose if the lot size is 1000 and for single sampling if we are choosing sample size as 50. Okay, in case of sequential sampling, we will end sequential sampling after 150. Okay, suppose that is the end. Anyhow, we are going to terminate the process. So after taking 150 samples, that is the meaning. Next, if the sample size selected at each stage is greater than 1, the process is usually called group sequential sampling. Okay, so here we are taking samples one after other. Okay, even while taking sample at once, if you are picking more than 1 units, so that is called as group sequential sampling. So here sample size will be more than 1. If the sample size inspected at each stage is 1, the procedure is usually called item by item sequential sampling. That means 1 unit by 1 unit. You are picking 1 unit and so you are evaluating whether that is defective or not. So next you are picking one, another, like that you are go on picking the samples one after other. So here sample size will be 1. So if the sample size is 1 in sequential sampling, then that is called as item by item sequential sampling. Next, so in order to in order to make a decision regarding whether to accept a lot or reject, so we have 2 approaches. One is we can go for graphical method or we can go for table method. Okay, first we will discuss about graphical method. For both cases, the equations are same. Equations to calculate acceptance and rejection values. Okay, they are same, but so we can represent it graphically or in the form of table. Okay, first we will consider graphical method. So in graphical method, abscissa means x-axis. Okay, the abscissa is the total number of items selected up to that time. That means so after 20 stages. Okay, what is the sample number? Okay, so that will be on the x-axis. Suppose if it is item by item, after 20 stages, number of samples taken will be 20 only. If it is a group sampling, so then group sequential sampling, then it will be more than 20, depending on the sample size. Okay, so on the x-axis, So we will consider number of samples taken at that time. So that is n. Next, the ordinate, that means y-axis, is the total number of observed defectives, number of defectives. Suppose at this point, okay, so it is the number of defectives observed after evaluating 10 samples. That is the meaning. Okay, here number of defectives after evaluating 20, number of defectives after evaluating 30, number of defectives after evaluating 40. Like that, so you are going to get the points and you will connect them, and that will result in a line. If the plotted points stay within the boundaries of the acceptance and rejection lines, another samples must be drawn. Here initially, so we will draw x-axis and y-axis. On the x-axis we will consider number of samples, on the y-axis we will consider number of defectives. Then we will get some points. Okay, we will connect those points. Okay, so next, these points so are decided by equation. Okay, xa and xr. Okay, there are two lines. Okay, so we are going to substitute the values of xr and xa. So we will plot them here. Okay, then so we will get these two lines. Okay, so you will understand the procedure later. As soon as the point falls on or above the upper line, the lot is rejected. Okay, initially using this equation xa, that is this acceptance line. Okay, this line, this inclined line is called as acceptance line. It is decided based on the equation this xa is equal to minus h1 plus sn. So this is rejection line. It is decided by the equation xr is equal to h2 plus sn. What do we mean by h2 sn? How we can find that? So all those things we will discuss in next slides. Suppose, okay, based on number of sample size and number of defectives, if you plot points, okay, if these points lie between rejection line and acceptance line, sampling will be continued. Okay, so this is this region, that means above acceptance line and below rejection line. So is a point where you cannot make a decision whether to accept a lot or reject. Suppose if a point lies below acceptance line, we can accept the lot at that stage, at that point. Suppose if the point lies above the rejection line, we can reject the lot. That means if the point lie above this rejection line or below the acceptance line, we can make a decision regarding whether to accept a lot or reject a lot, and we can end the sequential sampling there itself. So when we should continue is if the points fall above acceptance line and below rejection line, then we should continue with taking samples. Okay, here you can see at the end. So the point is lying below this line. So if you consider this location, okay, if you consider here, okay, so this is below the acceptance line. So this is the acceptance line. So for around 39, okay, so you are getting this point below acceptance line. That means, so after taking 39 samples, you can accept the lot, you can take a decision. That is the meaning. When a sample point falls on or below the lower line, the lot is accepted. So here you can see as soon as the point falls on or above the upper line, the lot is rejected. Suppose if the point fall on this line or above this, so lot will be rejected. When a sample point falls on or below the lower line, the lot is accepted. For example, here this point is below acceptance line, so then lot will be accepted. The equations for the two limit lines for specified values of P1, 1 minus alpha, P2 and beta are. So P1 means it is the lot fraction defective, okay, in lot 1, and this is the lot fraction defective in lot 2. So here 1 minus alpha is, so probability of acceptance when the large fraction defective is P1. Beta is probability of acceptance PA when the large fraction defective is denoted by P2. Okay, so this already we discussed in single sampling. Okay, so acceptance line is given by this equation. XA is equal to minus H1 plus Sn. This is the acceptance line, and XR is equal to H2 plus Sn is the rejection line. Okay, we are if we know H1, S and N values, we will substitute these values. Okay, you can see we are going to get XA and XR point depending on value of N. For 10 it is a different point, for 20 it is a different, 30 it is a different point. Then we will connect them and we will get a line. So that is XA and XR. Next, so you have equations for H1, H2, K and S. Okay, so in order to find S, you need the value of K, even H2, H1, you need K. So if you know large fraction defective value P1 and P2, then you can find out K using this equation. Next, if you know probability of acceptance when the fraction defective is P1, that is 1 minus alpha and beta. Okay, and K using this equation, you can find out H1. Similarly, you can find out H2 and S. Okay, so after finding H1, H2, K and S values, you can find out XA and XR values, and you can plot on the graph and you can get the line. Okay, consider a sequential sampling plan for which large fraction defective is 0.01 and probability of acceptance that is given by 1 minus alpha. So here you have only alpha, it is probability of rejection. Okay, probability of acceptance will be given by 1 minus alpha, so that will be 0.95. Okay, so 1 minus alpha will give you the probability of acceptance. So for that alpha value is required. Next, P2 is large fraction defective, beta is probability of acceptance. So here you have P1, P2, alpha, beta values. Then you can substitute P1, P2 values and you can get the K value. Next, after that you can substitute 1 minus alpha and beta values. So you will get H1, H2, then S value. Okay, so after finding K, H1, H2 and S values, substitute those values in this equation. Okay, so this is the equation of acceptance line and this is the equation of rejection line. So here H1 value is 1.22, so it is minus 1.22 plus S value is 0.028. N value it will vary. Okay, next rejection line. So H2 is 1.57, S value 0.208. Now based on this, so for this sequential sampling, which is having P1 0.01, alpha 0.05, P2 0.06, beta 0.10. That means you have large fraction defective values and also you have probability of acceptance value. If you have these two values, then so you can get the equation for acceptance line and rejection line for this particular sequential sampling plan. So this is the equation of acceptance line for this sequential sampling plan. This is the equation for rejection line for this sequential sampling plan. Okay, so this is the graphical method. So next you will substitute n values and you will plot the graph. Based on that you are going to make a decision. That is one method. Another method is, instead of using a graph to determine the lot disposition means it is making a decision regarding whether to accept a lot or reject a lot. Instead of using a graph to determine the lot disposition, the sequential sampling plan can be displayed in a table. Okay, so here again consider the same example where large fraction defective P1 is 0.01. So alpha value is 0.05, P2 0.06, beta 0.10, and it is for first 46 units. This is just an example. Okay. Now, after substituting the values of H1, H2 and S, so we have this equation for this particular sequential sampling plan. Now, consider first one, number of items inspected. That means it is 1. Okay, n value is 1. Okay, and so if n value is 1, okay, acceptance number, that is XA, substitute n as 1. Okay, 1 minus 2, 2 plus 0.028. So if you substitute n as 1, you will get it as a negative value. Okay, so acceptance number cannot be minus. Okay, in very positive scenario is 0 defectives. Okay, acceptance number is related to number of defectives. Okay, in very in a very ideal case. Okay, in ideal case or ideal scenario, acceptance number may be 0. That means number of defectives will be 0. But it cannot be negative. You cannot say number of defectives as -1, -2. It is not possible. Okay, if there are no defectives, it will be 0. If there are defectives, it will be a 1, 2, 3 positive values. So that means, so when you substitute n is equal to 1, and if you get a negative value, that means you cannot make a decision based on this value. Okay, you cannot make a decision at all. Okay, so so in that case, if we get XA value negative, instead of writing that negative value, we will write it as A. A means acceptance not possible. That means we cannot make a decision regarding this negative value. Acceptance not possible. Next, similarly, if you substitute 2, 3, 4, 5, okay, so till 44, okay, you will get negative values only. That means, so you cannot make a decision regarding whether to accept a lot. So until you take 44 samples. Okay, after taking 44 samples, you are getting a value 0. 0 means if there are 0 defectives out of 44, you can accept the lot. Similarly, if you substitute value of n in this equation, okay, so initially if you substitute 1, okay, n value as 1, if you substitute, it will be 1.57 plus 0.028. That means it will be 1.598. Okay, so now consider the number of items inspected, that is 1. So acceptance number, so you will get negative. Rejection number, okay, so if you substitute, it is a positive value, 1.598 you will get if you substitute n as 1. Now, even though it is 1.598, it is a positive, but we are writing it as B. Okay, what is the reason? Why we cannot make a decision regarding rejection, even though it is 1.598? That means you can round it off it to 2. Okay, so it is 1.598. So number of defectives will be in terms of integers. So you can round it off to 2. But then also here you cannot write it as 2. What is the reason? The reason is, so you are inspecting only one item. Okay, how we can fix rejection number as 2 when the number of items is only 1? Okay, it is not at all possible. It is not at all possible. So that's why rejection not possible, because here you have only one unit. You cannot fix 2 defectives for 1 unit. Okay, so that's why here it is written as B, rejection not possible, because XR value is greater than N value. Okay, so in that case, so you have to write it B. Next, you can see number of inspected items. You are inspecting 2 units, and if both 2 are defective, you will reject it. Now it is possible 2 out of 2 are rejected, you can reject it. But when there is only 1 unit, so either it should be 0 or 1. So 2 is impractical. Okay, so that's why we write it as B. Next, so if you substitute n as 2, once again you will get almost 1.59 something. Next, that will be rounded off to 2. Out of 2, if there are 2 defectives, so you can reject. Okay, or 2 or more, you will reject. Okay, so in this case, if it is 2, you will reject. Next, for 3 also, out of 3, if there are 2 are defective, you will reject the lot. Okay, like that, if you substitute n values to this equation, you will get rejection number. Acceptance number means XA values. Rejection number means XR values. Okay. So after performing 44, okay, until 44, you cannot accept the lot. Only thing is, so if you get more number of defectives equal or more than 3, you can reject the lot. Okay. So next, after taking 44 only, you can accept the lot. So like that, you should continue. Acceptance and rejection numbers must be integers. So the acceptance number is the next integer less than or equal to XA. So that means, so if the acceptance number is 1, okay, you will accept. So if the number of defectives are 1 or less than that, means 0. So no fraction values. And the rejection number is the next integer greater than or equal to XR. So if the rejection number is 2, if number of defectives are 2 also you will reject. If 3 also you will reject. More than 2 also you will reject, or equal to XR also you will reject. Thus for n is equal to 45, the acceptance number is 0 and the rejection number is 3. Okay, so here if you substitute n value as 45, for 45 you will get XA value as 0, 0.02, like that you will get a value. So here for XA you will get 0.04. So next, if you round it off, it will become 0. So that's why acceptance number is 0. Next, for XR you are getting 2.83. When you round it off to integer, it will be 3. Thus, for n is equal to 45, the acceptance number is 0 and the rejection number is 3. The lot cannot be accepted until at least 44 units have been tested, because here you can see till 43, if you substitute n values in equation of XA, you will get acceptance number as negative, which is not possible. So we are writing it as acceptance not possible. That means that is the value cannot be considered. That's why it is written as A. Meaning of A is acceptance not possible. So when you substitute n as 44, then you will get 0.02. So that will be rounded up to 0. Next, if you substitute n as 45 in this equation, so it will be 0. So that means, so till after taking 44 samples only, you are able to make a decision regarding whether to accept a lot. Rejection you can do, okay, after taking second sample itself we can reject a lot, but in order to accept a lot, at least you should take 44 samples for this scenario, for the given values of P1, P2, alpha, beta. So you should take at least 44. Okay, actually we don't know what will be the exact number, so we should continue with the procedure. The lot cannot be accepted until at least 44 units have been tested. The OC curve for sequential sampling can be easily obtained. That means operating characteristic curve for sequential sampling can be easily obtained. 2 points on the curve are P1, 1 minus alpha. So P1 is the lot fraction defective. This value is considered along x-axis. Probability of acceptance will be considered on y-axis in OC curve. So by considering these two values, you can get 1 point on the OC curve. Okay. So if there is a OC curve like this, on x-axis you are plotting probability of, you are plotting large fraction defective given by small p, and y-axis you are plotting probability of acceptance, PA value. Okay, 1 minus alpha is nothing but it is also probability of acceptance value when the large fraction defective is P1. Okay, suppose if this is the P1, okay, depending on 1 minus alpha, suppose 1 minus alpha is here, so you will get 1 point. Okay, similarly, next, if you know P2 value, large fraction defective P2, if P2 value is somewhere here, okay, next again you will take the corresponding beta value, that is probability of acceptance, if that value is here. Okay, so these are the 2 points on the OC curve. Next, the third point near the middle of the curve is P is equal to S and PA is equal to H2 by H1 plus H2. So using this, so you can consider one more value S. Suppose your S lies at this point. Okay, probability of acceptance depending on PA value. So you will get one more point. Okay, so next connect these 3 points with a curve that will be the OC curve. Okay, this is the procedure to draw OC curve in case of sequential sampling. In case of sequential sampling, you can draw operating characteristic curve. If you know the values of P1, P2, then yes, and also 1 minus alpha, beta, and PA value, which depends on H2, H1. Okay. Next, the average sample number taken under sequential sampling is given by these equations. Next, rectifying inspection. Okay, so already we discussed about rectifying inspection in detail. Okay, so rectifying inspection means when you reject a lot, that lot will be subjected to 100% inspection and all the defectives in that lot are replaced by good ones. That is called as rectifying inspection. Okay, so this is applicable only for rejected lots. Okay, because you are replacing the defectives in these rejected lots with good ones, the outgoing quality get improved. Okay, because in these rejected lots there will be no defectives. The average outgoing quality for sequential sampling is given approximately by this equation. PA is probability of acceptance, P is large fraction defective. Next, the amount of sampling is A by C. So A and C values you can find using these equations. If you know 1 minus alpha and beta, you can find A and P values. Even C you can find if you know P2 and P1 values. The amount of sampling is A by C when a lot is accepted and N when it is rejected. Therefore, average total inspection is given by this equation.